mile. So is everyone okay if I call this A? That's A, right? And this is?
B.
But they didn't give me C, so do you mind getting it right now?
Plus 1.
What theorem?
Pythagoras, right?
Not do Pythagorean theorem. And you go through the math, some people have already figured it out. It's a perfect one. 1. And when C is 1, like 0.6 squared plus 0 squared, C squared. C squared equals 1.0. What's the square root of 1.0?
1.
1.0. Wait, what about plus or minus?
You don't need it.
Length can't be negative, it's a length. So how far was this at that instant? 1 mile. Now I'm going to change color chalk. If you want to color code with me. Can we talk about the rates given in this problem? Because they did give you some rates. What was dCdt? And was it positive or negative? What did they say? The police determined radar that the distance between them and the car is increasing
So it's positive.
at 20 miles per hour. So I'm going to change my color, and I'm going to talk about how dCdt is actually 20 miles per hour positive. This is increasing. Because then what's happening a few seconds later? The police is what? There, and then the car is what? There. That distance what? See? So at that moment, the distance was increasing. Cool. Did they give us any other rates? Just one more rate they gave you. And look at the last sentence.
The cruiser is moving.
If the cruiser, that's the police cruiser, is moving at 72 miles per hour at the instant of measurement, what is the speed of the car?
Speed of the police
Gotta
car?
figure out that speed of this guy. Speed of the dude.
Dude, okay.
The speed of that what they call him, the speeder. So when the cruiser is going, what was it? 72 miles per hour? So Amber, do you know where I'll label like a D something letter DT and put 72 miles per hour? Because it's a rate, it's one of these. They said it was the cruiser, the police cruiser. They said he was going 72 miles per hour.
So DADT.
All right? That's an A. So I'm going to write, everyone over here, DADT
72.
equals
72
72, if you want to put the units, miles per what?
hour.
Now, I want you to look at something carefully. Look at this image. Look at this image carefully. Think about it a moment later, at this instant. What's going on with this length?
Decreasing.
Is it decreasing?
Uh-huh.
Guess what I have to do here?
Negative.
That's probably the hardest part of this whole section. I need you to look, observe that picture that you got, the sketch. Look at something and say, well, is this side increasing or decreasing? Well, that side's decreasing. The cruiser is heading towards the what? The intersection. The other side's increasing. The answer, dBdt, is what we're looking for. And the question we're looking for this problem, what are we trying to find? The unknown? Here it is. What is, I'm going to use
DBDT.
yellow. What is dBdt? How fast is that car going? Rate of change of the length B with respect to time. Cool. Why did I make this next? Because what? This whole length in this right triangle, we're going to call this letter A, and that length of that right triangle is going to shrink a moment later. It's going to look like that. Right? Cool. So at that instant, it was shrinking. Where do we start? Boop. Boop. Boop, boop. Now, everyone, I need you to differentiate everything with respect to what letter?
A, B.
T. All right. Do power rule. 2 in front. Decrease it by 1. What shall I write right next to it? DADT. Why? Chain rule. Why? We're doing this implicitly, right?
Mm-hmm.
All right. DADT. What does this become?
2B DBDT.
2B or not 2B? Yeah.
2C.
And then this one becomes.
2C DCDT.
Hey, if you want to, everyone in this class, if you get a lot of these problems, and you do in this section, look at all the 2's. What could you do if you wanted to make that thing easier to solve?
Factor on.
Yep, divided 2 on both sides. So I'm going to do that. You'll see it come up often. Look, 2, 2. I'll divide 2 on both sides of the equation. Some of you may just start right here on some of them. I mean, yeah, it's okay to just even start here. You might get tired of doing this every time. You may just start right there. Now notice there are 6 things to fill in. I believe we have 5 of the numbers. You should always have 5 of the numbers here. And then the 6th is the unknown. Just be careful with the positive and the negatives. What's that?
0.6,
It's DADT.
72, negative 72.
Good call. Negative 72. Right?
Just going,
Because that was shrinking. Good. You can imagine on the web assigned questions I get for online calculus for later rates. They did if I love them, they'll attach work. And I go, what's your question? I don't know, and I spent 2 hours on this. I'll find out and be like, it's double by big, that's negative. And everything will work out. What's that?
B is 0.8.
0.8. Oh, we don't know this. Unknown. Unless you want to call it X. Do you like to call this X? You can.
We're gonna leave it DBDT.
Yeah, I'm with them. Leave it DBDT. I'm with Art. Leave it DBDT. But you could make it an X if you're like one of these people. I like to always talk for X. What's C?
C is 1.
1. And DCDT was what, 20 positive?
20.
Now, how do you algebraically solve for DBDT?
So you have to take the 0.6 times 72, add them with 20, and then divide by 0.8.
Good call. Whatever that number is right there, it's negative. We'll add it on both sides. Do you want to see what it is real quick? What is that number? 0.6 is 72. 40, all right, so negative 43.2 plus 0.8 times DCDT equals 20. Let's add that on both sides, right?
Uh-huh.
You get 0.8 DCDT equals 53.2. And last step, what do we do?
Divide by 0.8.
Hey, our answer's gonna be positive. I hope that makes sense to you. Is that car increasing? I mean, excuse me, is this length right here increasing in size?
That's 63.
Oh, you're the best.
And also dB by dt.
Oh, you're the best. Right here, I want you to say, don't change the letter. In fact, I'm gonna keep that yellow. DBD. DBD. And DBD. And what's 63.2 divide 0.8? How fast are they going?
79
They're cruising, baby.
miles per
They're
hour.
flying, everyone.
That's not that fast though.
Yeah, I know, that's rush hour, you're behind everyone in rush hour. 79 miles per hour. What okay there? Great job. Try the second one. A ladder 13 feet long, pressed against the vertical wall. All that slides away. Make a picture though. Hey, you always start out by drawing a picture. Everyone, it doesn't matter which side of the wall I put the ladder on, true?
Uh-huh.
Is everyone okay if I put the ladder on the right side? I mean, I could have put the ladder here, I'll just put it on this side. There's my ladder. How long is it?
13.
The ladder is 13 feet long?
Mm-hmm.
Okay. What letter can I call that? See, everyone spots the right triangle already. I call that C. They see the right triangle already. That's C, that's 13. Now what else do they see? Bottom ladder slides away from the wall at 2 feet per second. Oh, but I'm gonna draw this picture again, everyone. I apologize. Maybe I shouldn't rush to my picture, because look at the end, they go, how fast is the top of the ladder sliding down from the wall when the bottom of the ladder is how far from the wall?
12 feet.
So maybe I should draw this picture like this, right? There we go. That's a little bit better image. If this is 12, this was what?
13.
Okay, that's C. I'll call this B. This is A.
5.
Did they have the big yardstick in here? No? No? Ooh. All right. I mean, let's pretend that's the ladder, right? I want you, as you're working this problem, to think about how the sides of that right triangle are changing. What sides are shrinking, what sides getting bigger? Can you see it? And that's what's going on here?
Mm-hmm.
You all see that right, as the right triangle changes, good. Can you get that on there?
Yeah.
There's your ladder, it's like it's sliding, we're talking about what's going on when that's 12 feet here and this is 13 feet long. But we all can tell that side is what? Decreasing. That length of that right triangle is decreasing, this length is increasing, right? Something funny was going on with length C though. Different from the car chase problem.
It's constant.
Good job. Outstanding. Oh, and this is different from the other problem in one case. That C value, she says, is always staying constant. It's always 13, right? It wasn't an adjustable ladder that there was changing throughout the whole problem. It was always 13, 13, 13, 13, so that's interesting. So I think I'll start there. And Brett, probably was the hardest part to this problem. Could have thrown us off. They won't tell you DCDT. Do you want to know why? If C's always 13, then how fast is TC, how fast is it changing? It's not changing. So it's always going to be what? 0. Does that make sense?
DCDT would
That's
be
right.
0.
There you go.
Because it says it rests, yeah.
Right? Because that ladder is always going to be 13 as it slides down. It's constant, never changes. Cool. Now, did they give us any other rates? What was this 2 feet?
2 feet at
Go
the bottom of the
45.
ladder.
All right,
slides
where's the
away.
bottom of the ladder?
The B.
There. So when they said this, there's the bottom of the ladder, so they're talking about this length here. Look, bottom of the ladder, and then they said something about it's going away from the world at a rate of 2 feet per second, so that's a B, so dBdt positive is 2 feet per second. All right, I've got B, I've got dBdt. I've got C, I've got dCdt. I'm stuck, how do I get that?
5. That's your
How'd you get that?
13 square minus 12 square.
Pythagorean theorem.
It's a perfect
It's
triangle
it's
though.
one of the
Oh, you got those memorized. Anybody else know these?
I saw this
That's
one.
the only one I know.
I love that. That's smart if you know the common right triangle lines. 3, 4, 5, 6, 8, 10, 5, 12, 13. Anybody know any others?
1, 2, root 3.
What was it?
Is it 1, 2, root 3?
No. Oh, 1, 2, root 3. Yeah, that works. There's a 1, 2, root 3.
1, 1, root
I mean, 1, root 3 too.
Yeah.
I'll go down to work. Anybody know the one that starts with 8? 8, 15, 17, and my favorite, 7, 24, 25. I don't know if you'll see that one too often, but you'll probably see these. It just saves like a minute of work to do Pythagorean theorem, right? Hey, thanks, you saved me a minute. So a lot of you knew that was a 5. I'm gonna put it. Well, what's the unknown in this problem?
The
DADT.
DAD.
All right, try it, see if you know it'll work.
So DADT should be negative, right?
That's right, he goes, your answer should come out negative.
Can I?
Expect it, expect it, expect it. Your answer should come out negative, he's saying. Expect it.
Can I interject one second? Because what
Sure.
happened is, if you look at it in a Cartesian coordinate, x is increasing, so the DADT has to be increasing, and y is decreasing, so that has to be negative,
That's right.
right?
Yeah.
You can do that way too.
It's very good, Art, seriously.
Thank you, sir.
It's really good.
So,
All right, here we go.
square
A squared plus B squared equals C squared. And then 2A dAdt. It's like differentiate both sides of the equation.
DADT plus 2b
2B dBdt.
DADT.
2C dCdt. What can I do with all those 2's?
So 2,
Get them out.
so 2c dCdt, you can say that that's 0.
Right? I love that. Did everyone see what happened over here?
Yeah, so,
Love it. Because that's C0, you're 0.
and that's why.
Now, I do like to take these 2's off, so I think I'll write it like this. Okay. That's 5. That's dAdt. That's 12.
2.
That's 2. Alright, what do we get? Subtract 24 on both sides, divide that.
By 5.
My answer is negative. Was it supposed to be negative?
Yep.
Yeah.
Mm-hmm.
You can leave it like that unless you want to make that a decimal.
4455
But you gotta write units.
Negative 4.18
Is it feet squared or feet?
feet per second.
feet per second.
Feet per second, very good, because we're not talking about area here, we're talking about length. Feet per second.
Because usually the other ones are feet per second, so we can DADT 20 feet per second.
Yes.
So, Alan, basically all related rates are kind of like a velocity.
Yeah, you're right.
Right.
They're all velocities. We're always finding velocity. Every time, he's right. At an instant. So go, flip it on the back side, let's go 3-dimensional. What is it? All right, there,
Okay,
it's a
water.
cone.
Conical tank, 9 feet per cube.
Now, water runs into a conical tank. The tank stands pointed down, has a height of 10. Let's draw a picture. Conical tank. All right, pointed downward. Has a height of 10, base diameter of 10. Okay, not drawing a scale I want, but that's 10. This is 10. And 10. How fast does the water level rise?